and welcome to the Home Assistant How-To with Bearded Thinker. Today we're going to work with high growth plant sensor. We'll start in a couple of seconds. Before we begin today's episode, I really would like to thank all the members who have joined my channel. Thank you for your support. And now, let's get back to the video. Today we are going to play with this sensor. This is LilyGo TTGO HiGrow sensor. There are a lot of similar boards like this. This one has sensors for measuring the amount of minerals inside the soil. This one is for measuring the water composition of soil. Then we have, of course, temperature and humidity. And also here, let me try and find it, should be, I think this is the one, should be also the illumination or lux sensor. Some other nice features of the board is that it has USB-C connector, pins here, but it also has connector here for the battery, which is great because the board also contains a charge controller, meaning that you can hook up battery like this, or you can hook up the 18650 battery, and then you can use it independently of the external power supply. The board itself does have its own GitHub page where you can find code that you can flash on it, and it will work as web server, meaning that you can connect to the board and read the values there. But great thing about this board is that it also has ESP32, and since this is the ESP32 board, it can be programmed. Pesor or pair has public Git repository where you can find a new, better, improved custom firmware that will turn this board into board that speaks MQTT, and that way you can hook it up in Home Assistant. This video will cover everything, meaning that we will cover on how to install Arduino if you don't know how to do it. After we install Arduino, I'll also cover downloaded the INO or sketch file, installation of the required libraries, some specific non-standard libraries, and also customization of one of the libraries. We will also be working on calibration of this board in terms of the detection of water inside the soil. And at the end of the video, I will also cover how you can integrate it with Home Assistant and receive information from the board inside Home Assistant. There are two more things I want to share with you before we proceed with the installation and configuration. First of all is that if you connect USB-C cable here, it will start charging the battery. When there is a bright red light, hopefully you see it. When there is a bright LED light, this means that the board is powered, but it's also charging the battery. When this red light begins to dim or almost dims down completely, that means that the board is still powered by the USB-C cable, but charging has stopped. First thing that we have to do is we have to download Arduino. For this, follow the link I'll be posting down in the description of the video. If this is your first visit, agree and proceed. Next thing is to download the Arduino IDE. You have to select download link based on the operating system you are using. I will be using Windows Installer since this is the fastest way for me to download and install the Arduino. If you want, you can of course make a donation. Donation helps support Arduino software or Arduino projects. Let's click just download. And Arduino should download very quickly. After you have downloaded the installation file, click on the file to start installation process. Press on I agree. Install everything that you see here. Install with the default values.
install in the default location, and wait until the installation process finishes. It will not take that long. If you are prompted to install drivers, press on Install, and now the installation of Arduino IDE is complete. Let's press Close. Next step for us is to go to GitHub, to repository, where we can find the latest code for the high growth sensor. This is the official page for the LilyGo TTGO HiGrow sensor. This is the full name of the sensor. Let's check what is the current version. Versioning. Current or the latest version is 1.6. If there are any changes to the code or if there is any update to it, you will have to repeat the following process. Click on the code, click on the download zip, and this will download the zip file with the current code. We really need only one file, but it's always good practice to download the full repository. Inside this folder, TTGO HiGrow MQTT master, there is INO file. This is the Arduino code file, and this is really the only file we will be needing. So if you do not want to download the whole repository, what you can do is you can go to TTGO HiGrow MQTT master folder, click on this file, select raw, and just save this file somewhere. What I'll do, I'll go to desktop, create new folder, name it Arduino files, go inside that folder and save it here. Please note that before you save it, that you have to replace the extension. Extension should not be text file, txt. It should end with .ino. If by mistake you did save it with text file, it's very easy. All you have to do is you have to go and rename file. At this point, what we did install Arduino. We also downloaded the code from the repository, this code here, and we can now open the sketch file inside Arduino. Let's open it up. Arduino will now load. Yes, create folder. And here is the code. There are some settings that you will have to change, but we will go through them a bit later. They need to be customized according to your system setup. But first things first, we need to install dependencies, and dependencies or libraries are files that contains bits and pieces of the code that make this board work. Let's start with verify. It should fail very fast. Let's look at the code, and it says that we are missing bh1750.h, this one here. We'll repeat this step for every library we are missing, but there are some odd libraries that we will not be downloading directly using Library Manager. Instead, we will be using links I'll also provide you in the description of this video. So first library we are missing is bh1750. bh1750, and let's search for it. This is the name of the library. We will just press install. Close. If we try now to compile, we will receive the error we are missing the ht file. Manage library, dht. If we go down, we will see that there are various DHT libraries, and we need official DHT sensor library by Adafruit. Let's press install. Install DHT sensor library only. Close. Compile. We are now missing BME280. and the library is called Adafruit BM280, so we will install this one. Let's press compile. What we are missing here is Adafruit sensor, and we do not see this library listed here. And what does that mean is that our Adafruit BME280 requires additional libraries, and one of the libraries is Adafruit sensor. Let's try this one, Adafruit Unified Sensor. Close, compile. For this we will have to visit specific web page and do a couple of additional steps. Okay, so the problem with the NTPClient is that if you would use the standard library NTPClient, Network Time Protocol Client, you would end up with the error. There is a fix for ESP32 boards, and this plant sensor is using ESP32 board. So this is the fix. We have to download the NTPClient library. Let's show in a folder. We will extract it to NTPClient-master. Let's go to downloads folder. Next step, according to the documentation, is to rename folder to NTPClient. We will remove master and dash. If we look inside, we can see that here we have library for the NTP. And according to the documentation, next step is to move the NTPClient folder to your Arduino IDE installation libraries folder. If we go to Documents folder, Arduino, Libraries, you will see that here are other libraries we installed. So what we have to do is, let's go back to the folder where we unzipped. We can just cut and paste the folder here. So we have now solved also the issue with the NTPClient. Since we didn't use manage libraries inside Arduino, Arduino itself doesn't know about this library. So what we'll do, we'll press Ctrl S to save any changes we made, although we didn't make any changes, but it's always a good practice to save. We'll close Arduino and we will reload it once again. Now let's try to verify or compile our code. As you can see, we now have fixed the issue with the NTPClient. Next library we are missing is Arduino JSON. JSON library. And let's press install here. Let's close this. Let's try to compile this once again. We see that we are missing PubSubClient. PubSubClient is used for MQTT. So what we'll do now is we will install this library. PubSubClient. Latest version is 2.8.0. Let's press install. And this library is also now installed. Let's verify this. We are now missing driver adc.h. In order for Arduino IDE to know how to work with ESP32 boards, it needs additional board information. For you to install it, you have to add ESP32 boards, and as you can see, they are not listed here. So what we have to do, we have to define this board, and this is done through preferences. You have to add them here. This is the additional board manager URLs. You have to paste here the URL, and in order to do that, let's do some web search. Let's select this link, for example. We will not be watching the tutorial. What we'll do is we will copy this URL. Of course, you can file that exact link down in the description of the video. Let's paste it here and let's press OK. Now let's go to Tools, Boards, Boards Manager, and let's search for ESP32. As you can see, now we have boards available here. Let's press on Install, and let's wait for the download of the board definitions. Okay, this is now installed. Let's press Close. Let's go to Tools, Boards, ESP32 Arduino, and let's select board ESP32 Dev Module. As you will see, we now have different options here. One thing that you may notice here is that we now have here some devices or ports available, but in order for us to get the exact port number of that board, we still need to hook this board to our computer. Before we do that, let's try and verify code once again. We still didn't get any error. And as you can see, the sketch has now successfully compiled. The hardest part of this integration and firmware compiling is done. Now let's go and define some values. If you are just playing with the sensor and you still do not want to install it permanently or put it in a case or leave it outside, and especially if you are having any kind of issues, I would definitely suggest that you change this logging to true and read log file to true. If you are done with the installation of the sensor, before you put it in a permanent place, I definitely suggest that you change this to false, as leaving it to true can cause battery drain. Next thing that we have to do is we have to define the type of DHT sensor we will be using. This is one of the issues that pesor had with the sensor. Let's go to the web listing. The web listing clearly states that the board is arriving with the DHT12 sensor. But as you've probably guessed it, no, it doesn't. The board arrives with the DHT11 sensor, meaning that both the original code for this firmware that's now been changed into version 1.6 and the firmware you can get from this page here, the site where you bought your board, will not be working. pesor or Per was trying to find out why, but it seems that there is currently a lack of the DHT12 sensors, so the board is not shipping with a sensor that looks like this. Instead, it ships with a sensor that looks like this. As you can see, it's a bit larger. Don't be afraid, the board will still work. So by looking at your board, you will have to see if you are using this a bit larger sensor or this one a little bit smaller. Here you can see the difference between the two sensors. So this one is DHT12 and this one is DHT11. When you've located your sensor on the board and you cannot miss it, it's a big chunky blue box, you have to go back to your code and here you have to define what sensor you are using. So if you are using a larger DHT11, you can leave this uncommented, but if you're a lucky one and you did receive DHT12 sensor, you just uncomment this line. Next thing is for you to define your SSID and password. This will be used for boards to connect to your Wi-Fi, so the board has to be in the range of your Wi-Fi network. Let's select this, my SSID, and here you type in your password, my Wi-Fi password. Of course, don't type this, type your real SSID and your real password. Okay, the next couple of steps are a bit more critical. You will now have to make selection that I can help you, but at the end it's all up to you. So those two lines here are needed for the MQTT. pesor named them device name and device placement. The easiest way for me to describe you is if you look at the MQTT tag and how MQTT topics look. This one is the top level one. So this can, for example, be Home Assistant. Or in case of the show me plant sensor. This is me flora, I think. And for this demo purpose, I will call this one MQTT. So this is a topic, and it's used in the MQTT integrations to sign or subscribe to topic, and everything underneath will be then looked at and read. In this example, I'm using MQTT. Pesor named his own greenhouse because he's keeping his plant sensors in his greenhouse, so he wants to know based on the topic where those sensors are located. Device name is really a plant name or a pot name or something that can help you identify this sensor if you have multiple sensors. I'm still working on my setup. Currently I only have one plant sensor, as I still do not know at what pot this sensor will be located. Will it be in flower pot, tree pot? I will call this plant 1. Each time when you program this board, if you're having multiple boards, you have to make sure that this device name changes. For the next board it will be plant 2, plant 5, plant 107. It all depends on how many boards you have. Now that we've done this, we also have to define the MQTT. For the test purposes, I will be using my test MQTT server. It should be on 192.168.1.201, and if everything is working correctly, it should also report on the default port 1883. At this point we have more or less configured everything. I just want to give you a warning. If you are, as me, using Synology and you are using MQTT as the independent Docker file or as a package installation on your Synology, and you didn't configure your username and password for MQTT, this should work. If on the other hand you are running some different installation, for example running HasIO with the MQTT add-on, you will need to create a user here or to input existing user here. The simplest way to do it is to go to your Home Assistant, Configuration, Users, and add here a username of your choice. You do it by pressing the plus sign, give it a name, test MQTT for example. This now will also be the name that you will be using as a username inside your MQTT for login, and here you type some password, test MQTT. I will press now cancel, but you need to press create to create new user. I already have here user for the MQTT, it's called plants, and after you created your test MQTT user or plants user, you just type here the username and password. While I was testing this firmware on various installations ranging from the Synology with the different versions of the MQTT, the issue I was having was the issue with the MQTT add-on inside HasIO, and it required username and password to work. Before we do anything else, there is one slight change that is needed. Unless we do this change, we will keep receiving error after we compile our firmware. To do this, we have to go to File Explorer in the folder where we are keeping libraries. We need to go to PubSubClient. We have to go to Source src, and let's open up this file. We will scroll to the place where we see this. This is MQTT max packet size, and we will remove 256 and replace it with 2048. Let's save this and let's close this file. At this point sensor is configured, but if we go a little further down the code, you may see this line here. Every sensor is built the same way, it uses the same components, but since those components can be made different in the factory, can have different composition, I don't know, probably some more solder or not on them, more resistance, everything is not calibrated 100%. It's always a good idea to calibrate the sensor before putting it into the permanent position. So how do you calibrate the sensor? The easiest way to do is to connect your sensor with a USB-C cable to your computer. Next thing, make sure that you have selected here ESP32 dev board. Upload speed, I recommend 115/200 because on higher speeds you sometimes can get a gibberish or errors. CPU frequency you can leave default, same with the flash and all the other values. One thing you have to select here is the COM port. If you have multiple COM ports seen here, the simplest way is to disconnect the board, like this, go to Tools, Ports, and you will see that now I only have one port here. If I reconnect, COM6 port will be visible. Now we will flash the firmware, but this will be a temporary flash, so we can get those values here. There are two values we are interested. Default values in the sketch file are 1400. This is resistance when the soil is 100% moist or contains water, and 3400 when there is no water, meaning that, for example, you have sensor just hanging around in the air without touching anything. Let's press this upload. And we now have to wait until the sketch is compiled and uploaded to the board. While we are waiting, you can go to Tools, Serial Monitor, and here you will see the output of the sensor after it finishes compiling. As you can see, the file has been compiled successfully and it's now been flashed to the board itself. We have now successfully flashed the board. The board itself connected successfully to the Wi-Fi network. It received the IP address. This is the MAC address. It's successfully connected to the broker. If we now look at the numbers here, we can see that we have soil before mapping, and the value is 3255. So we just replace this 3400 with the value 3255. And let's save this. Next thing is that you take a glass of water, few centimeters, because we only want to get the bottom part of the sensor inside the water. We insert it into the glass with the water, and we then upload it once again. Or the next option is you can avoid uploading and you can just press the reset button on the board. This is the button that is more towards the top. And at this point you see that we have number 1689 as a number when this sensor is submerged into the water. You can press the reset once again to make sure that this is correct number. So 1627. We will replace this with 1627. At this point our sensor is calibrated. There is additional calibration that you can do, and this one is in regard to the battery. If you have a multimeter, you can charge the battery to the maximum and then here write the exact number of volts without the decimal point. So for example, if you see 4.16 volts, this will be 416. The second number is the number we presume the battery is flat, and for the lithium-ion batteries it's always a good idea to don't drop below 3 volts, so 300 is a great value for this. At this point the board is done, everything is flashed, we have calibrated the board, we didn't upload the latest firmware, and since we now did insert the last value here, this one, it's also a great idea to upload the latest sketch. And now we have calibrated our sensor. If you look at the numbers here, you can see that soil before map is this value. And this value here is the map value in terms of percentages. So we can go from 0 to 100%. Next part of this integration, will be done inside Home Assistant. Let's go to File Editor. And let's scroll to the bottom of our configuration.yaml file. Here I will paste the code I prepared previously. This is the code. And what you have to do is you have to customize it based on the values that you used previously in the firmware. So we have here MQTT and plant_1. And if we go back to the Arduino, you can see that we used here MQTT as a device placement and device name was plant_1. So what you have to do, you have to customize every state topic to match the ones from your code. There are a lot of them, but you can use find and replace it with the code you need. Okay, let's save this. And first part of the code is done. At this point, after we restart Home Assistant, all the data from our plant_1 will be available through MQTT integration. Let's go to Configuration, Server Control, check configuration, and if everything is okay, we'll press here Restart. Work on this sensor is not complete. I know that there will be a couple of other features added, probably some fixes in the future, trying to make things much more easier in terms of setup. On the one hand, you want to go with the as simple as possible solution. On the other hand, you want to optimize both code and the battery usage of the device because you don't want to recharge it every day, week, or even every month. So this is the reason why there is no web interface for this sensor, and instead you have to manually inside code change some things. On the other hand, I'm working with Per, or better to say, I'm trying to help him, and as I'm no programmer, it takes a bit longer for me. We are trying to make this work with the MQTT discovery, meaning that topics itself will be created based on the device ID. So there will be even less configuration needed for this to work inside Home Assistant. And that, together with the Home Assistant integration, will allow you to more easily edit and to not just add but also to control more than one device. We are still waiting for the data to become available. Everything is now loaded. What I'll do now, I'll press reset or reboot button on the plant board just to make sure that there is a new data available for the Home Assistant. So after our server has rebooted and I have pressed reset on the board, if we go to Developer Tools, we should see plant information here. Let me create a new tab here. We call it plants. Let's press save, add, and we'll add all the entities we are now receiving from the plant sensor. And this is the last time the sensor was updated. Save. So this is the information that the sensor is providing. You can see some anomalies here. For example, since this is currently not inserted into the ground or plant soil is 0%, also plant salt is at 0, which is not something that you will see if you are using this sensor inside the soil. Second thing, you can notice here that the plant battery is over 100%, and the reason for that is that this sensor is still hooked up to my computer. What you can do is, if you have external battery, I've posted the link in the description of the video for the batteries we are using, and there are also some tweaks for this board to work with the 18650 battery. which is somewhere between 2000 and 3000 milliamp hours, and the small batteries I've provided links are from 500 to 800 milliamp hours, and the bigger battery, the longer it will work on the battery. So depending on the battery you are using, once again, it should be 3.7 volts, 3.7 volts. This board is also charger. When I unplug it and when I reset the board, which currently I am doing, it will start operating on the battery, and the next time the sensor updates, which should be very fast, as you can see here, you will receive the status of the battery. Why I see 96%? The reason is that I haven't calibrated in the source code what is the maximum voltage of my battery, and it is expecting, I think, 418, so 4.18 volts, and probably my battery doesn't output that much. So it starts with the value 96%. At this point, you have been watching this video for the last 11 hours. Just kidding, it was a very long video, but I tried to go in as much detail as possible and to cover every possible aspect of what you can encounter during the installation and configuration of this board. I would definitely once again want to thank Per for pointing me into this direction, also for notifying me that he is working on this project. And I am very happy that I was able to do at least one or two very small, minor, you wouldn't notice things, because it feels that I'm also giving back something to the community, not just recording videos. Support for this can of course be found on the GitHub page. If you have issues or if you have some suggestions, you can always go to GitHub. But also you can find me on the Discord if you have any kind of a question or a problem with the compiling of the firmware, some ideas of what should be added in the firmware itself, or how to even better optimize it or redo it. Please contact me via Discord, and I will definitely keep Per in the loop and see with him if we can do anything to improve this board. Thank you once again for watching this video. If you did enjoy this video, please give me a thumbs up. If you think that this sensor is a great idea, also give me a thumbs up. If you have any kind of a comment or a question, give me a thumbs up. But you can also leave the comment on my Discord server, or you can leave it here in the comment section. Thank you once again for watching this video. Until the next time, bye bye and have fun!